welcome to my short lecture on the subject Smart Cities and Communities. Now we will discuss Module 3 and Unit 2, that is Sustainable Green Building. Now suppose if you want a city to be having a smart city infrastructure, then it becomes very necessary to develop sustainable or to follow sustainable green building practices focusing on energy efficiency, resource conservation and environmental responsibility. And if you want to have eco-friendly building designs, then it should be integrated with smart technologies to create healthier, more sustainable urban environments. And you should aim to create regenerated buildings, and you are to leverage data to optimize energy consumption and the use and the management of resources in buildings and utilities that may be waste, water and energy. The World Green Building Council has defined green building as, in its design, construction or operation, the building should reduce or eliminate negative impacts and can create positive impacts on our climate and natural environment, thereby preserving precious natural resources and improve our quality of life. So what are the key aspects if you want to have a sustainable green building? The first thing is energy efficiency and renewable energy integration. Green buildings can reduce energy consumption by incorporating energy efficient systems like solar panels, smart HVAC systems, LED lighting systems and IoT-enabled energy monitoring systems. Rather than relying on fossil fuel-based power, if you are incorporating renewable energy sources like photovoltaic panels, we will be able to achieve carbon neutrality, we will be able to reduce CO2 emissions, we will be able to reduce global warming. The next key aspect is improved indoor environmental quality. The green building should be designed in such a way that there will be a natural lighting system, natural ventilation system, and in order to build it, we should as much as possible use non-toxic eco-friendly materials, thereby creating healthier indoor environment for the occupants. If you want to build a green building, then you should try to use materials with low environmental impact like recycled steel and concrete, bamboo and other sustainable options, non-toxic paints and adhesives. Plus the building should try to have green infrastructure like green spaces such as parks, green roofs, urban forests. All of them will contribute to a healthier environment. Like we see in Chennai, some bridges, overbridges, which are provided with vegetated walls, they help in regulating temperature, managing stormwater and improving air quality. Next comes resource conservation like water conservation. If the buildings in smart cities are provided with rainwater harvesting systems, water recycling technologies, low flow fixtures, then they will help in the smart cities to promote water conservation, and these features will also ensure sustainable water use, especially they are essential for urban areas facing water scarcity. Then comes waste management. If you say a building is green, then it should be capable of doing efficient waste segregation and recycling. We should create smart waste bins, and based upon IoT this can be done, and this will be playing a crucial role in reducing landfill contributions. Next comes smart technology infusion. If the buildings are integrated with smart technologies like IoT, AI, automation these all enhances building performance, resource management and occupant comfort. Electric vehicle charging infrastructure. We should also encourage the occupants to rely on EV instead of the normal vehicles. So if all these are integrated together in the single building, then it will be called as a sustainable eco-friendly green building, there are certain certification agencies which will give certificates to green building rating systems. Some of them are LEED, G, Griha, etc. With this, we will close the session. And welcome to a short lecture on smart cities and communities. Now we will be discussing Module 4 under Unit 2, that is safety. When we tell a city is smart, then it means that we are leveraging data and technology to enhance city security, and this involves implementing systems for crime prevention, disaster management and public health. In saying so, the citizens who are living in such smart cities should be made safe, and the environment should be made more livable. The initiatives for achieving this city security often include elements like adaptive traffic control systems, city surveillance systems, efficient solid waste management, and integrated command and control centers, all contributing to the city security and safety. Now there are two layers actually, functional layers and safety layers. Functional layer, they will be focusing only on the core component of the system, and the safety layer will be incorporating components designed for user, system, environment. Then comes the digital security. Actually, in a smart city, we are using data and as well as technology to optimize the performance of the city operations. So we will be generating all sorts of data from various sectors. So you have to safeguard these types of data, especially personal information, intellectual property information, industrial system, from theft and misuse. Then infrastructure security. When you say infrastructure security, it means that we are to ensure adequate infrastructure that includes 24 hours water supply, sanitation, good energy systems, transportation, etc. Then comes personal security. People living in such smart cities should be protected from terrorism, natural disasters, conflicts, violence, etc. For example, people who are living in cities, if they come across severe cyclonic storms, then it is a natural disaster state from which the citizens should be protected. Then comes public health security. For example, we were facing COVID situation between 2019 to 2020, and during such conditions we were under lockdown, and this is one of the public health security measures. Such measures should be provided in a city to mitigate the impact of health crises, and we have to strengthen the health systems to protect lives and economies. Then integration and data. Smart city infrastructure actually relies on interconnected systems that generate data, and they are used to optimize resource allocation, improve performance, and enhancing safety and security. Now, what are the examples? Suppose if you are a citizen living in a smart city, you are having a car, you are going somewhere and you want to park your car, then there should be smart parking. Smart parking is a system which is being allotted with the sensors and real-time data, and this will be guiding drivers to available parking lots, thereby reducing congestion and accidents. Then comes intelligent transport systems. People living in smart cities should be having good experience when they are traveling all over the city, and this can be achieved by optimizing traffic flow, by improving emergency response times, by enhancing road safety. Then all over the city should be provided with surveillance cameras and sensors, and this will be helpful in monitoring public spaces, detect potential threats, and assist law enforcement in investigation. Then emergency response system. Suppose if there is a condition in which the city is to be flooded from a nearby dam, then we are to inform the people who are living around to evacuate, and they should be informed about this and this can be achieved by emergency response systems. But there are some challenges and considerations. First comes the privacy concerns, and if you are going to install a surveillance camera, even though it enhances safety and security, it also leads to the individual privacy intrusion, which is a challenge. Then we are achieving the smart city concept by leveraging technology and data, so such data collected should be kept safe. And integrating various smart city systems to work seamlessly together requires careful planning and coordination. Citizens are belonging to different categories, even though they are women, children, or elderly, disabled person, all should be capable of accessing the services in an equal manner. With this, we'll close the session. Hello and welcome to my short lecture on the subject Smart Cities and Communities. Now we will be discussing module number 3 on unit number 3. The topic is how to conceptualize the smart urban transportation system. So in order to talk about how the smart urban transportation system is evolving, we need to discuss first what are the 3 key drivers that are leading to the pushover for the smart urbanization regarding mobility. The first driver is urbanization. In order to earn the livelihood, more people from villages are coming and settling in the cities, and this will lead to congestion in the traffic, and in turn the users may find the transport experience poor. The next key driver that leads to this pushover is digitalization, the advent of ICTs, etc. The third key driver is climate change and resource efficiency. Approximately 15 to 20% of the emissions comes from urban transportation. So there is a strong push to make these systems more efficient and smart. Next, we need to discuss what are the 2 elements in this paradigm shift. The 2 paradigms are ownership to usership and separate transportation system to mobility system. Rather than owning a car, if you are using the vehicle you want to use, that is advantageous rather than having a own transportation system. If you are trying to use different kinds of transportation mode, you will be carrying less, and this will lead to some sort of mobility devices, that is multimodal transportation system. Digitalization. The use of ICTs in the transportation system may help improving urban transportation systems in terms of user experience and safety. ICTs can also monitor urban transportation infrastructure, and they can also be used to create automated driving vehicles. Now, there are 3 layers in the transportation system. First one is infrastructure, the next one is data, and the other one is service layer. Now when it comes to infrastructure layer, if you want to have ICT, you want to equip in transportation infrastructure layer with the data gathering devices such as video cameras, speed cameras, sensors for traffic detection like IR, laser, RFID, as well as wired and wireless communication. So because of this, there might be some direct implications in the infra layer. Now the managers have to pay attention to the interaction of this legacy transportation infrastructure to the new data infrastructure. Next comes the implications in the data layer. Actually, the data is collected from different channels and they are to be used for ICTs, and the implications may occur in the reliability. We have to check whether the data is complete or incomplete, holistic or not. Then the data is gathered from different channels and it may of different format. So the first thing that you have to do is you have to do standardization. Then the more important implication is data security. Once the data is gathered, you will be able to obtain accessibility and adequacy, quick response and safety. Then comes the service layer. Instead of making the manual driven cars, if you are going for machinization, that is, if you are transiting human driven cars into self-driving cars, then you need to have some automation with the help of data like traction, stability, brake status, mileage, hours of travel, etc. And this data will be collected using ICTs. Now, when it comes to automation, when it comes to self-driving cars, there are different levels of driving assistance or automation ranging from 0 to 4. Now, level 0 means it's completely relying on the human being who is going to drive, so no driver assistance. Level 1 means one driving assistance can be provided to the human being, like braking. Level 2 means driver benefits through driving assistance, for example, cruise control and braking assistance. Level 3 is conditional automation. The vehicle will be automated only under cases where human intervention is appropriate. At that time, the manual factor will be used. Level 4, completely high level automation with no human intervention at all. And in order to achieve all these, in order to achieve this automation, we need to go for V2V communication, V2X communication, etc. And the vehicles are to be provided with data processing and communication technologies to achieve this. And these vehicles are to communicate with road signs, traffic lights, speed limitations, road conditions, etc. And this will lead to implications in the service layer. For example, suppose in case if accident happens, then who is to be blamed? That becomes the question. Whether the driver is to be blamed or the automation is to be blamed. Who is to be blamed? That becomes the question. So these are the factors that you have to consider when you are trying to conceptualize the traditional transportation systems to the smart urban transportation systems. With this, we will close the session.